So this is another percentage calculation in stoichiometry, and it's mainly to do with environmental science. So it's basically looking at the total mass of what you want and hoping to get that as 100%, so there's no waste and no byproducts. And so it's another percentage one. It's not percent yield, but it's percent of useful as opposed to non-useful stuff. And so the formula in your data booklet is this one: molar mass of side product, molar mass of all reactants. I don't know if that's clear enough to understand what's going on. So basically there's a stoichiometric ratio here, which are these numbers, these small letters representing numbers like 2 or 4 or whatever. And so you need to times whatever the molar mass of A is by that stoichiometric number to get the full mass on one side, and hopefully it equals the mass on the other side, and there are no byproducts, but obviously there are in this reaction here. So that'll tell you, hopefully it's 100% or quite high, and that'll be one indicator that it's better than some other reaction to try and be good for the environment. So you also need to consider a lot of other things. So these are taken from parts of the 12 green chemistry principles, so there's almost 12 in there. So you need to consider other things as well. Okay, so can you just come up with a completely different chemical that's much safer? Are there dangerous solvents or processes involved that wasn't considered? Is it energy efficient? Does one have a catalyst and it takes a lot less energy to create? Are the chemicals for the reaction safe and renewable, or is the other one better? And can you get rid of the product easily, or dispose of it easily, or can it degrade easily? So there's just a couple of things that show that atom economy is not the end and all of having something that's environmentally friendly. So let's just go through some practice questions. So define the atom economy of the equation on the left. So you're starting with this one, and then you're just adding this, and then adding this, and then adding this, and getting to this here. So we're not quite sure if there are wastes there, but that is assumed the product that we want. So you'll soon find out by adding them together. So 206 is the one we want. There's the 134, the one, and this one over here, and this one over here, and this one over here. That adds up to 206, then there were not any hidden byproducts coming off that weren't reported, and it doesn't. So this is not a fully explained equation. There's stuff in there that's coming out that we're not told about because the atom economy is not 100%. So 77% is the answer for that one. This one here, it's all 1:1, so that makes life easy. We're not having to do any of the timesing out, and that's obviously the waste because that's the PVC that we want. So that assumes organic chemistry, I'm afraid, so I'll just let you know that now. And that is the waste product. That will be turned into a polymer. Okay, so basically the reactant is this, and so you have to add all those up and you get 98, and the product is this one here. And so you add all that and get that. That's just splitting it apart. So formula, substitute units, and the answer is 63%.